Okay, so this is the Faxitron X-ray system completely torn down. This was the second Faxitron X-ray unit that I picked up that was damaged in shipping. And this has been completely torn down with all of the circuit boards and relevant components stripped out of the steel frame. So here is the main power supply for the unit. This is an Aztec LPQ 252 DC switching power supply. It has outputs of positive 5 volts, an adjustable output which is set to plus 24 volts, as well as plus or minus 12 volt outputs. And it has a SIP header here, which has I/O pins for remote power on and off and power good, which are used by the unit. As configured, the Faxitron units have several wire bundles coming out of the supply. The 5 volt, all of the plus 5 volt lines in the Faxitron unit are color-coded blue. Ground lines are colored either black or green, and they seem to be all tied together throughout the black and green lines seem to be all tied together throughout the whole unit. Plus 24 volts is red. There is another red wire in the unit for an interlock. That should not be confused with the plus 24 volt power. The plus 24 volt power only goes to the X-ray filament control board. And then it also has positive and negative 12 volts. Negative 12 volts are brown, and positive 12 volts are orange. Now, in the case, when this is installed, those lines will go to a set of fuses located on the back of the X-ray filament control. It has an 8 amp fuse for positive 5 volts, 5 amp fuse for positive 12, and 2 amp for negative 12, and the plus 24 volt line is not fused on this board, but rather it's fused on one of the fuses on the front of the filament control board. So those lines are distributed through 3 main cable bundles. One of the cable bundles goes to the bottom of the unit where the Hamamatsu flat panel detector is located. This carries positive 5 volts on the blue line and ground on the green and black lines, and positive 12 volts on the orange line. The positive 12 volts is not used in the Faxitron DX-50. So here is the removed Hamamatsu flat panel detector and the power converter board for that detector. The power converter board isolates the flat panel detector from any switching noise from the main power supply and provides separate isolated low noise outputs for the analog and digital control circuitry in the flat panel detector. This has 2 DC-DC converters, both put out a little more than 5 volts, and then it has a pair of linear regulators which regulates that down to plus 5 for the analog output, analog circuitry and the digital circuitry, and those in the analog and digital circuitry are on separate power buses so that switching noise from the digital circuitry doesn't get into the analog circuitry. So this power connector would just plug into the power converter board as shown here, and this red line is positive 5, and then 2 grounds and positive 12, and positive 12 isn't used. And then the outputs are just 2 separate positive 5 lines and some grounds. So that's really the only way that the flat panel detector interfaces with the rest of the system. It's controlled over USB interface. It just has a power connector from the main power supply. When you turn the key on the front panel, it opens the remote inhibit lines on the SIP connector. The power supply turns on, and the flat panel detector is powered up. Other than that, everything from that is controlled over the USB. Now the other header connectors, one goes to the back of the CPU control board, shown here. This header carries, just put that there. Starting from this side, it carries a ground line, then not connected, then a ground line from the power OK output from the power supply, then negative 12 volts, then the power OK line, then positive 12 volts, then not connected, then positive 5 volts. So basically this screw header just carries the power, it's just a power connector from the main power supply, and it also has the power OK line, but other than that, that's it. Moving on to the rest of this board, the connector up here is the serial port, so this just runs out to a serial header in the back of the unit for RS-232 at 9600 baud to control the Faxitron system. This header here seems to be a jumper, just contains a jumper of sorts. This contains analog control lines from the filament control board. This just plugs into there. The flat flex cable on this side of the board runs to the display, the LEDs and button switches. And then this header here is just for interlocks. So speaking of interlocks, this right here is the breakout for the door interlock system. This has a rotating platter, which used to house the door of the unit on this side. And on the top, it mounted the interface for the X-ray tube, and this would lock down in there, and then the X-ray generator would, the shielding box for the X-ray generator would then fit here on top of that platter assembly. And this would then, the X-ray tube would then bolt down to here, and this one, the X-ray tube was broken in shipping, but this is the beryllium window for the X-ray tube. The beryllium window itself is right here. This is 32 thousandths of an inch thick, so it's very rigid structurally. You'd have a hard time fracturing the beryllium window. So this seems to have been vacuum brazed into a stainless steel collar, which was then silver soldered into this main flange. There was some glass here, but I took this onto to interface the tube. This was likely an Invar metal or Invar or Kovar metal stub. I've taken this on the lathe and I've just turned off all that lip where the glass is. And as a reminder, do not ever machine the beryllium window. The dust is toxic and flammable, particularly so the oxide, so don't machine, sand, grind, etc. Inside the tube, there is also the anode assembly. Here, this also had a Invar or Kovar collar brazed onto it, and then that went to the glass on the tube, and then inside the tube was cathode. It has a control grid cup and then the filament connector, so that was positioned like this inside the X-ray tube, and the X-rays would come out through the window. And it was a glass envelope tube, so the X-rays would also come out everywhere else but that was what the shield box is for. Looking inside the shield box, there's the input for the high voltage through this plastic bushing. The high voltage is generated by a gamma high voltage XR15-35P high voltage power supply. This will go up to 35 kV. The tube was supplied with 0.1 milliamps of current. High voltage came out of this little pigtail. There's a banana plug here for the high voltage. The banana plug was centered inside the plastic bushing, and then it comes out to an insulated wire which went onto the X-ray system anode. Now, meanwhile, inside the box, the cathode had a glass multi-pin feed-through. It has 3 pins, 2 for the filament, 1 for the grid, and that plugged into the pigtail, which was then connected to the cathode assembly. Inside the box, there's also an interlock switch, so if you take the top shielding, see that it's a steel box, but it also has lead shielding on the inside. If you were to take the top of the box off, the interlock switch would open. Those interlock lines come out here to the filament control board. Green and brown are from the interlock switch. So looking on the filament control board, starting from this side, this is just the pigtail that goes to the X-ray box. There's a fan connector ground, which is black. Filament line, which